presentation on muscles. I'm Colleen.
I'm Bianca.
And I'm Alejandra.
These are some important vocabulary for you to keep in mind as we go throughout the presentation. The origin, which is the attachment of the bone and muscle. It does not move during contraction. And the insertion, attachment of the muscle to the movable bone.
We're also going to have the flexation, which is going to be the movement decreasing the angle between two parts, along with the extension, which is going to be the movement increasing the angle between two parts.
And the last two are going to be the agonist muscle, which is the muscle that's going to be primarily moving, and it's going to be the one that's being contracted, and the antagonist muscle, which is the muscle that works against the agonist.
Something to keep in mind when you're looking at birds' muscles, which is really interesting, is that the pectoral muscles are a large muscle that attaches from the humerus or long arm bone, the origin, to the main portion, which originates from the sternum, or the keel, as it's called in birds, because the pectoral muscles depress the wings of the shoulder, and the supracoracoideus, which is the agonist muscle, mainly is responsible for elevating the wing. The smaller movements, like steering or turning, are controlled by the tricep, biceps, and other minor muscles. Can you move your arms like a bird?
All right, I'm going to be covering the muscles in felines, jumping cats, specifically in caracal cats, also known as the desert lynx. They can jump up to 10 to 15 feet high in the air and are also excellent climbers. So my next question is going to be, why can these cats jump so high? They have strong hind legs, big three muscles that I'm going to be covering, and powerful muscle fibers found within them, also known as IIX. So for the first muscle, they're going to be the quadriceps, which are going to be the agonist, anti-agonist muscles. They're going to be located in the front of the thigh, and they're going to be responsible for extending the knee joint. This muscle group provides the primary force for the lift-off from the ground during a jump. We also have the hamstrings, which are going to be the agonist muscles, which are located in the back of the thigh. They play a crucial role in the jumping process by flexing the knee joint and extending the hip joint. This action allows the caracal to generate additional power and propel itself upward. And for the last muscle, we're going to have the calves. They work together to plantar fix the ankle joint, which is the action of pointing the toes downward. This is going to provide a necessary push-off force from the ground during the jumping motion. So what makes these muscles so powerful? One specific fiber called the IIX is a type of muscle fiber that contracts quickly and generates a high amount of force. These muscles and muscle fibers work together in coordination to generate the explosive force necessary for the caracal to execute its jumps.
Next, I'm going to be talking about the bicep and tricep muscles within primates, starting with the upward motion. In an upward motion, primates lift their arms up using the bicep muscle to pull the arm closer to the shoulder. This muscle is considered the helper muscle in this movement. Meanwhile, the tricep muscle acts as a brake to slow down the lifting motion as a way to prevent overstretching of the bicep. Now the roles switch whenever the primates are moving their arms in a downward motion. The tricep muscle becomes the helper by straightening the arm, while the bicep muscle slows it down in order to keep it steady. This teamwork of the bicep and tricep muscles helps primates move their arms smoothly and precisely. So a good example of an animal that can give us a better visual of these muscles being used day to day is the gibbon monkey, as these mammals are known for their monkey swinging ability to get by from branch to branch. When a gibbon monkey reaches out to grab a branch, their bicep acts as the agonist muscle, contracting to pull their body towards the branch. Meanwhile, their tricep muscle works as the antagonist muscle, providing resistance as a way to control the movement and avoid swinging too forcefully. As they release the branch to swing forward, the roles switch. Now the tricep muscle becomes the agonist, extending to push the body away from the branch, while the bicep muscle acts as the antagonist, controlling the swing and preparing for the next grab. This alternating use of the agonist and antagonistic muscles allows the gibbon monkey to navigate through the trees with agility and precision. And lastly, our question for you is, would you rather have muscles to move like a bird, a cat, or a monkey, and why?
All right, thank you. And does anyone have any questions?